Hello students, and you're welcome back to solve your physics past question class. First question here, which is from the year 2016. It says calculate the capacitance of a capacitor that stores 0.03 capacitance of charge at 15 volts. So to calculate the capacitance of capacitor, we must use the formula Q equals to CV. Now we are calculating the capacitance of capacitor. So we have to make C, which is the capacitor, the subject of formula. So we have C equals to Q over V. So then we have C equals to 0.03 all divided by 15. So when we do that, we have 0.002 farads, which can also be written as 2 millifarad as our final answer. The next question we have here is from the white past question 2017. It says a capacitor with 2 microfarad is charged to 25 volts and then disconnected from the source. Find the energy stored in the capacitor. So to find the energy stored in the capacitor, we use the energy stored in the capacitor to be half CV square, where C is the capacitor of capacitance or capacitance of capacitors, and we have V to be our voltage. So we have half CV squared to be half times 2 times 10 to the power minus 6 times 25 square, just as the values were given from our questions. So we have half times 2 times 10 to the power minus 6 times 625, because 25 times 25 will give us 625. So when we further divide these by 2 and we further multiply this, we have 625 times 10 to the power minus 6 joules, which can also be written as 625 microjoules as our final answer. The next question we'll be solving in today's class is from the white past question 2018. It says if a 7 microfarad capacitor is connected in a series with a 14 microfarad capacitor and the total voltage across the combination is 21 volts, find the voltage across 7 microfarad capacitor. Now, to find the voltage across 7 microfarad capacitor, the first thing for us to do is to calculate the equivalent or the total capacitance of the whole series. Now, to find the equivalent capacitance, we have 1 over C equivalent capacitance is equals to 1 over C1 plus 1 over C2. We're given the first capacitor to be 7 and the second capacitor to be 14. So when we plug in this, we have 1 over equivalent capacitance equals to 1 over 7 plus 1 over 14. So we can use 14 as our LCM. So we have 2 plus 1 all divided by 14, then which is equals to 3 divided by 14. So when we cross multiply, we have the equivalent capacitance to be 14 divided by 3 microfarad, which when we further divide this, we have 4.67 microfarad as our equivalent capacitance. Now, the next thing for us to do is to find the quantity of charge. So to find the quantity of charge on the whole capacitance, we use the formula Q equals to equivalent capacitance times the voltage. So we have Q equals to 4.67 times 10 to the power minus 6 times 21 volts. So when we multiply this together, we have 98 times 10 to the power minus 6 coulombs, which is equals to 98 microcoulombs. Then to get the voltage across the first capacitor, which is 7 microfarad capacitor, so we use Q equals to CV. Now, remember what we're looking for is the voltage across the first capacitor. So we have Q equals to C1 V1. So the voltage across the first capacitor on the first capacitor. So by making V1 the subject of the formula, we have V1 equals to Q all over C1. So plugging this into our formula, we use the quantity of charge, which is 98 times 10 to the power minus 6 all divided by 7 times 10 to the power minus 6. When we divide this through, we have our voltage to be 14 volts. So 14 volts runs across the first capacitor, 7 microfarad capacitor in this question. The next question we'll be looking at is from the white past question 2019. It says a capacitor of 8 microfarad is connected to a 30 volt battery. Calculate the energy stored in the capacitor. To calculate the energy stored in the capacitor, we use the formula half CV square. We have 1 over 2 times 10 to the power minus 6 times 30 square. Voltage is the 30 and our capacitor is our capacitance is 8 times 10 is power minus 6. So when we further solve this, we have 1 over 2 times 10 is power minus 6 times 900, because 30 times 30, which is 30 squared, give us 900. So when we thoroughly divide this by 2 and we multiply by 900, we have 3600 times 10 to the power minus 6 joules, which can be further written as 3.6 millijoule as our final answer. So the last question we'll be looking at into this class is from the wide past question 2020. It says a 9 microfarad capacitor is connected in parallel with 6 microfarad capacitor across a 18-volt battery. Calculate the total energy stored in the capacitor. So to calculate the total energy stored in the capacitor, we have to find the equivalent capacitance. We're given 2 capacitors that are connected in parallel. So we use the formula, the total capacitance equals to C1 plus C2. So we're given the first capacitor to be 9 microfarad and the second capacitor to be 6 microfarad. So by plugging this, we have total capacitance to be 9 microfarad plus 6 microfarad, which is equals to 15 microfarad as our total or equivalent capacitors. So the next thing for us to do is to now find the energy stored. So we use our formula, which is E energy, which is E equals to half CV squared. So the C there is the total capacitance of the capacitors, and the V is the voltage from our questions. So when we plug in this into this formula, we have half times 15 times 10 to the power minus 6 times 18 squared. So we have half times 15 times 10 to the power minus 6 times 324. So we have, so when we further divide this, we have 2430 times 10 to the power minus 6 joules, or it can be written as 2.43 millijoule as our final answer. So this is where we are going to stop into this class. We hope with what we have learned into this class and across the previous classes on capacitor, we've been able to better and equip you with the right knowledge on the concept of capacitor. So stay with us as we solve more questions in other areas of physics in our subsequent classes. Bye for now.